So go ahead and download the example Excel file. And basically, if you look on the first sheet, it should say skew data. I've shown you 3 different little data sets. Data set A is skewed to the right. Notice that it has a tail to the right. Data set B is skewed to the left. Notice that it has a tail to the left. Data set C is more normal. It's more symmetrical, basically. So it has a little peak here, but it's roughly symmetrical on both sides. Now, the nice thing about Excel is that it does have a skew function. So you could automatically generate skewness. And the skew function is just skew. And you put in the data that you'd like it to calculate. And this is showing you a skew of 2.0, 2.08, 2.09, basically saying that it's very, very positively skewed. Now, I could just drag this across, and it'll calculate the skews for the data sets above. So this one is for this data set, and we find it's a negative skew, almost as negative. So the extent is almost as negative as this one, right? So this is about +2, this is about -2. And it's because these two are largely mirror opposites of each other, so they have similar skews. Here we see the skew is closer to 0. It's still sort of on the positive side, but it's closer to 0 than it is to, 2 or 3, right? All right. So SPSS, if you're interested in the particular formula that they use to calculate skew, you could double-click, and when this little, it's like a little helper window comes up, you'll notice that skew is a hyperlink. If you click on that, then you should get this little window that comes up. That's an Excel help window. Let me make this bigger. Here they show you the exact equation that they use for skew. Notice that this part is exactly what we talked about. It's that distance away from the mean cubed over standard deviation cubed, right? And so that's all sort of the heart of the function. But here we have this extra stuff, n over n-1 times n-2. So you could use that, you could use something else, you could use 1 over n-1, that's also very common. I'll be using 1 over n-1. All right, so if you hit enter, let's look a little bit first, before we calculate skew for ourselves, let's look a little bit at what it would mean to our measures of central tendency to be skewed right or skewed left. So let's calculate the mean. So mean is average. Sometimes I type in mean and Excel's like, eh. I'm going to close my parenthesis. Let's also get the median while we're at it. And let's get the mode. Once we have those 3 values, I'll move this up a little bit. Once we have those 3 values, we could actually just copy and paste straight across. And it'll find the respective mean, median, and mode for each of these other distributions. Now, let's look. When it's skewed to the right, and there's a very positive skew, what we find is that the mean is greater than the median, which is greater than the mode, right? And that makes sense. The mode is probably going to be on the very, very left side of the distribution. And the mean is highly affected by outliers, and the outliers are on the right, so the mean is going to be greater. For negative skewed distributions, we have the exact opposite pattern. This time, the mode is the greatest, followed by the median, then the mean. Remember, the mean, highly affected by outliers. This time, the outliers are small, so the mean is being pulled to the smaller side. The most frequent numbers are up on the higher end, and that's why median and mode tend to be bigger. And so when you know the skewness, you automatically know sort of the relationship between mean, median, and mode. On the other hand, when distributions are largely symmetrical, when there's very little skew on either side, then what we see is that the mean, median, and mode are often very close to each other. Sometimes they'll be exactly the same. This time they're just very, very close to each other. And that makes sense because the skew is a little bit, because there is a little bit of skew, it's not exactly on top of each other. Now let's talk about how to calculate skewness. So here I've put the formula for skewness. Also, another way you could write this formula, let me insert another row here, because sometimes people aren't comfortable with sort of moving around that sigma sign. It's sort of like, where should I put it? Where does it go? That sigma will affect some things and not other things. That sigma will affect anything that has an I next to it. Because of that, you could put sigma and put the divided by standard deviation cubed in there, and it won't affect it very much. You could either do this part after you add them all up, or you could do it before you add them all up. It actually doesn't matter because of the law of distributive property. Yeah, distributive property. So you could either put this inside of this, or you could take it out. It sort of doesn't matter. So let me show you a way that you could write this. Actually, this might not be helpful to write it on Excel. I'll write it when we go back to our PowerPoint slides. All right, so let's start with this. We know that we need to get all of these distances away from the mean, right? So let's start with that and cubing that. So I need to start with an equal sign, and I'm going to put in a parenthesis to say take my value, subtract the mean, which would be the average here, and I'm going to put in all of these values. Now, I don't want that average to jiggle around, so I'm going to lock that data in place. And because I want to copy and paste it later on, I'm actually going to even leave, I'm going to leave the A to vary. But I'm going to say lock the 4 down. When I copy down this column, it won't change the A column. But when I copy across, it will change it. So I only want to lock down the number row. Then I'm going to close that parenthesis and cube that value. Now here I could also divide by this as well, but I'm just going to do this for now. So this is just the part where I'm doing x minus x bar cubed. That's all I'm doing in this column. So I'm going to go ahead and copy and paste that all the way down. And here what we have is just this part. But now I need to sum them all up and divide by s to the 3rd power as well as n minus 1. So I'm actually going to modify this to make my formula a little bit simpler and have n minus 1 down here. All right, so here you could see now I need to add these up and also divide by n minus 1 times standard deviation cubed. So here, let's do that. Let's sum these guys all up. And then divide by count. So count my data, minus 1, right? And then also multiply that with standard deviation of my data cubed. It's a lot of parentheses, right? And because it's color-coded, I know I need one more blue one. to signal my denominator. And I'm going to hit enter. And there we get a skewness. I get a skewness of 1.84. That's quite close to the 2 point something that we got using the Excel function. The Excel function, it just multiplies by a slightly different constant. So that's the only difference. But once we have this, we could actually copy this over here. And so here, if I double click on this, it shows you that it's using the C column because I had let C vary, and so it's being relative about the columns, but it's locking the rows in place. And so I could also check down here. It's using the C column to count those data and also get their standard deviation. And what we find is negative 1.7, which is pretty close to the negative 1.9 or so that we found with Excel's function. And then I'm just going to copy and paste all of that again to our approximately symmetrical one. And we get something quite close to the 0.44 that Excel gave us, 0.39, right? And so that's how we're going to calculate shape here.